Hello, everyone. Do you hear me? Okay, thank you. Thank you. Hello. And I want to share my slide. Okay, mm, and do you see the slide? I don't know. Okay. Okay, thank you. Okay, I think all of the things is okay, and we can start the session. Okay, thank you. Okay, welcome to this session. We want to talk about data acquisition and data processing. I am Toktam Ghaffarian. I have a PhD in computer engineering, and my major is cloud computing, data science, and also machine learning. Let's start the session to know what we want to talk about in this session. You often hear data is a new oil. What is the meaning of this sentence? The crude oil is not so valuable. And if you want to use the oil in the industry, we need to refine it. It is the same for data. If you have data and just store this data in some storage system, you can't extract the valuable insight in the data. And if you want to to access the value of the data, you should refine it. And in this session, we want to talk about data refinery. We call it data pipeline, and we talk about different steps in a data pipeline for the big data. What we learned during this session, step by step, at first, I talk about what is big data and how it is generated. After that, I jump to the data journey during explaining the data pipeline and how there was and how a data pipeline works. I talk about the modern data storage system, data warehouse, data lake, and lakehouse. And at the end, we will see together a case study in the Netflix a streaming system, and we want to see the different steps in a data pipeline. Okay. At first, I want to define big data. What is big data? Maybe you think about, oh, big data is a large volume of data. If we have a large volume of data, okay, it's big data. Yes, it is one of the characteristics of the big data. In the past, when we talked about big data, we mean terabytes, 10 to the power of 12. But today, now, when we talk about big data, we talk about zettabytes of data. It is equal to 10 to the power of 21. And you can't store this data in one machine. You need a distributed system to store such a big volume of data. But big data has another characteristics. We have 5 V's for big data. The first one is volume, and we talk about this. The second one is velocity. Velocity is the speed at which this data is created. When you work with a real-time system, the velocity is very high. And in the big data science, we have sometimes the speed of generating this data are so high. The third one is variety, the diversity of data type of this data. This data can be image, video, voice, social media post, text document, any things you can imagine can be a big data. And this is the variety characteristics of big data. The fourth one is veracity. This data should be reliable, and we need some steps to validate this data in order we can assure to this data. And the last one is value, the insight we can extract from this data. Okay, this is a definition of big data, and we want to go the active paradigm. We have it these days. In the old, we have passive paradigm. What's the meaning of passive paradigm? In the legacy system, we treated data as a record of past. For example, you store the last transaction of a chain market on the table, and the value for you is the storage. If we want to ask about this data, you can say, oh, I can archive this value or this history of this data. The analyze of the past paradigm is retrospective. What's the meaning? We analyze the past. What happened last quarter? What happened last week? The revenue of this market is dropped last week. Why? But it is happened. And then in the passive paradigm, you search or you look for a solution for it. But nowadays, we have another paradigm, the active paradigm. In the active paradigm, data is treated as a fuel for the present. Okay? the data continuously generated. You ingest this data, you process this data, and you can analyze this data at this moment. For example, sometimes you can see you search something in a Google, and some seconds after you see all of the things in this platform change to according to your search, and you told, oh, it's magic. No, it is not magic. Google has a pipeline, a streaming pipeline behind this, and it is analyze it right now. Okay, in the active paradigm, the analyze is real time and predictive. We can predict the future. Another example can be Uber. You use Uber. Uber has a real-time data pipeline, and instantly, and after you're looking for a driver, instantly match rider with your match this ride with a suitable driver, and calculate the dynamic pricing based on the traffic. It is the active paradigm, and in this session, we want to talk about the active paradigm. What is happening in the active paradigm? Okay, we want to work with the active paradigm, but what is the infrastructure challenge for us? Can we use the on-premise server? We have it traditionally. We have three challenges when we want to work with the big data. The first one is the scalability wall. What is the meaning? In the real-time data pipeline, sometimes we have a data spike and we should handle it. If you use on-premise server, because they have a fixed capacity for the storage and also for computing, they crashed. And you can't handle the bursty traffic on this server. Because of this, I need another infrastructure. The infrastructure that provides for me elasticity. Elasticity means that I can expand the computing power. I can expand the storage as I need. And when the data is explode, we can increase the computing power. For this one, the solution is cloud. The second one is integration. In the big data world, we have different type of data, and we should integrate these different type of data to each other. And if you want to use a legacy system, this system can't handle this type of data. But by using the modern pipeline, you can handle this challenge in your system. And the third one is latency requirement. Most of the pipeline is real time, and I need a very, very short latency. And the traditional system can't afford this latency requirements for me. Because of this, in a new paradigm, we need to switch to the cloud infrastructure. Okay, we want to start the data pipeline. As you know, if we want to start anything, the first stage is the data, how this data is generated. We have three types of data generation, as you can see in this slide. The first one is born digital data. What is this data? Born digital data is created directly in digital form, and it can be created by human or machine. For example, when you fill a survey, you create born digital data. When you write a post on social media, you create a born digital data. And this data is generated by human. When you work with a system and got the system output, it is the born digital data. The second type of data generation is sensor-generated data. As you know, we live in an IoT world. The sensors scattered around us to measure different things, to measure temperature, humidity, wind direction, your health by using the wearable device, and some of them in your laboratory. We call this data sensor-generated data. And the third one is scientific and experimental data. The data which is created by a satellite, by telescopes such as Hubble telescope, microscope data, and any of them. This is the scientific and experimental data. Okay, data is generated, and we want to work with this data. When you come into the computer science context, we classify data into three parts. The first one is structured data. Structured data is a data which is organized in rows and columns, such as Excel table. You, all of you, work with the structured data, and it is so easy to handle, to manage, because all of the record in the table has the same format. The second one is semi-structured data. In semi-structured data, we have some organization, but not in the table form. For example, email. In email, you have sender, receiver, title, body. You have some structure, and we call it semi-structured data. The level of difficulty to manage this data is medium. And the last one is unstructured data. Unstructured data is a data we don't have any clear structure in it. For example, image, video, voice, your social media posts. All of these things are unstructured data. I can answer your question at the end of the session. Okay, thank you. Back to the session. We want to know what is the semi-structured, the big data is most of the time is semi-structured data or unstructured data. And we want to handle this type of data. Do you have any problem in seeing the slide? No?
No, we can see the slides.
Okay, thank you. Okay. We want to start the data pipeline journey. As you can see in this figure, data is generated. For example, in this figure, we have a server-like data, and we want to ingest this data into our data pipeline. In the data pipeline, as you can see in this figure, we have some process. I don't know why it is back. Oh, okay. Okay. We have some process in the data pipeline, and these processes are used to move data from the external source. We talk about it, and then transform this data into the format which is suitable to do analytical dashboard, to run analytical dashboard on this data, or to run machine learning model on this data. Okay, I don't know why it is go back and forward. And okay, we can go to the next slide. I hope it's okay. Okay, the first step in your data pipeline is data ingestion. As you can see, this is a data ingestion. In data ingestion, you want to transfer data from source environment into the centralized storage. To store this data and then process this data. Okay, ingestion means transferring data. Transferring data, okay, from the source source of source file, and that generating this data, and we want to transfer this data to the storage system. This data can be structured data, can be semi-structured data, or can be unstructured data. Okay, when you want to ingest the data, we have some common data access interface for data ingestion. For in some systems, you can ingest this data from the application databases, such as PostgreSQL or MySQL table. You can get this data by calling a web service by using the API and ingest this data. We can get this data by using the streaming platform, such as Apache Kafka. We can get the any streaming data. You can get it from the file storage system, or you can get it from the data warehouse or data lake. When you ingest this data into the data pipeline, this data can be JSON file, can be structured table, can be semi-structured like, or flat file format, or a streaming event record. As you can see, after ingesting the data, you have a variety type of data that you should handle this variety type of data. And this is the characteristics of big data. Okay, I want to transfer this data. In the computer science, we have two kind of ingestion. The first one is batch ingestion, and the second one is continuous ingestion. I don't know what is the problem. Okay. In the batch ingestion, we collect the data. I don't click on anything.
Hi, for some reason we can click on the arrows, and I think people are clicking it without knowing it changes it for everyone.
Okay, but oh, okay, I want to go back. Okay, I hope it's okay. Okay, in the batch ingestion, we collect the data at a scheduled interval. For example, we collect the data every 2 hours, every day at night. And we can use manual or semi-automated workflow for collecting this data into the system. Batch ingestion is good for static data sets, and we have some popular software for batch ingestion. You can use Apache SQL, Spark Batch, or AWS Glue. But the second one is continuous ingestion. In the continuous ingestion, data ingested as it is generated. The data is generated, we transfer it. The data is generated, we transfer it. This is the continuous ingestion. Well, we have a very, very low latency because as data is generated, we ingest it into the data pipeline. And we need, in the continuous ingestion, fully automated pipeline, as we talked in this session about the fully automated pipeline. We have different tools for the continuous ingestion. It can be Apache Kafka, AWS Kinesis, Apache NiFi can be used for the continuous ingestion. Okay. Okay. If you have continuous ingestion, you should use cloud infrastructure. Why we need cloud infrastructure when we work with the continuous ingestion? The first reason is scalability. As you know, in the continuous ingestion, we can have data spike. Sometimes we have a bursty, in this ingestion type, we have a bursty data. And we should handle fluctuating of data volume. And in the cloud, because of the elasticity, you can handle it. The second reason is availability and reliability. We need a system that can ingest data all the time, okay? And it should be available all the time. It should be fault tolerant. If some error is occurred, the system should cover this error immediately without the user can know about this error. And in the cloud infrastructure, we have this capability. And the third reason is automation and integration. You ingest data inside one cloud storage, such as Data Lake, and you have different services in the system that you can run on the ingested data. And these three reasons is the main reason we should use cloud infrastructure for handling the continuous ingestion. Okay, we ingest the data into the data pipeline, and we store this data in a data lake, for example. What is the next step? We need to check the quality of this data. When you check the quality of the data, we call it data validation. Okay, in data validation, we have 4 objectives. The first one is a structural validation. We check this data for the schema. This data has all the required fields. The type of all of the fields inside a record is okay. If some field should be number, it is number. If some field should be a string, it is a string. If some field should be a string, but with a specific format, for example, for password, you have a string, but you need a specific format. You need, for example, some number, underline, or a special character, and also some character. You should check all of the data for the format we want to have this data. After we check it for the structural validation, we check the data for content validation. We check all of the fields for a missing value. And if we have a missing value, we check this data. We check the data for range or for boundary check. We check the data for any duplication. If we have the duplication, we check this one. And also, we validate data for consistency. What is the meaning of consistency validation? In a data set, some of fields are related to each other. For example, we have one field for marital status, and we have another field for name of husband or name of your wife. When you select the marital status single, and system allow you to enter the name in the name of your wife or your husband, these 2 fields are in conflict because I ticked I'm single, but I enter the name of the my husband or my wife. And in the consistency validation, in cross-field logical consistency, we check this consistency inside our data. In the referential integrity, we check the relationship between a different table. And in temporal one, we check the relationship which is related to timing. For example, you have a rental car system, and in this system, the time of pick of a car should be less than the time of you return the car. And we check, and these 2 fields are related to each other by the timing, and we check it in the consistency validation. And in the 4th one, we check the data for a statistical quality check. We check data for the outlier. What is outlier? Outlier is a data which is very big or very low. For example, for the temperature of a room, if you can see 150, oh, it is outlier, and we should tag it. We can check the data for the statistical distribution. If data followed some statistical distribution and you can see, and you see the abnormality, maybe something wrong happened in your system. Okay, in data validation, we checked the data. Oh, we checked the data. Oh, I don't have my slide. Okay, go back slowly. Okay, everything is okay. Do you have the slide?
Yes, we can see it.
Okay, thank you. Okay. In the last phase, we tag an error in a data by running the validation process. After this, we should repair this error, and we call it data cleansing. In data cleansing, we remove all of the error we find in the last part. We find it in the validation part. And in data cleansing, we have four parts. The first one is a standardization. In a standardization, you fix the structure. This is for the structural validation. For example, your date is not in a standard format. You can convert it to the standard format. You can have imputation. In imputation, we fix the content validation. All of the error we have, and we find it in the content validation. For example, a value is missing or invalid. You can fill this part of data by unknown, or you can fill it by average. We can use for that part of the data. We can run deduplication. Deduplication used for fixing consistency. For example, you ingest data from different data sets, and you have the same record for one student inside your data, and you should merge these two records with each other and create one golden record. And for statistical validation, we can use filtering or capping. For example, you have an outlier. A salary is $100 billion. It is outlier. You can remove this row, or you can lower it to the maximum limit. When you remove, we call it filtering. When you lower it, we call it capping. Okay, we clean the data, and we can go to the another phase. This phase is data integration. In data integration, because we have in the system different type of data, and we want to integrate, to merge these different type of data together, we can do two activity. The first one is semantic differences. What's the meaning of semantic differences? I have a data from different data sets. These two data has the same things, but is labeled differently across these two systems. For example, in one of the data set, I have surname. In the another data set, I have last name. When you want to integrate these two data sets together, you should use just one label for this column of your data, and you can use surname or last name, just one, for integrating these two data sets to each other. And maybe you can have the structural differences when you want to combine two data sets. As you can see in this example, we have two data sets. In this data set, we have three columns. One of column for ID, the other one name, and the third one, for example, date of birth. Okay. In the data set A, we have the same, but all of these columns are joined together as a value of this record. This record is the structure of this record is key value, and inside the value, I have these three columns. If you want to integrate these two data sets, I should convert data set A into the three column way, and then integrate these two data sets to each other. This is the structural difference. We handle it in the data integration phase. Okay, we talk about the phases we run on a data as a data transformation. In this slide, I want to tell you where we should transform the data. We get the data, store it, and then transform the data. Transformation means running validation, cleansing, and integration. Okay, or no, we ingest the data and then running transformation, and then store this data on a storage. When you back to the data science book, we have two architecture. The first one and the old way is ETL. ETL means extract, transform, and then load. Okay, in ETL, when we extract the data, we transform it before storing the data on a data warehouse, for example. This is the old way, but the new way is ELT. ELT means we extract the data and then loading the data inside the data lake and then transform the data. You can see the difference between ETL and ELT in this slide. In the ETL, as you can see, data is transformed before loading into the target system. In the old system, we use ETL because the storage are very expensive, and we should keep away all of the trash data from the data set, and then we can store the clean data onto the data warehouse. What is the disadvantages of ETL? if you have an error in the cleansing process of your data pipeline, you miss data forever because you don't store data in some platform before transformation. But the new way we use it nowadays is ELT. Data is loaded first in a data lake, and then we transform. If we have any error in the transformation process, we don't lose the data because we have raw data and we store raw data in some location inside the cloud. When you use ELT, you should use the cloud platform because we need to do another service for transforming this data inside the cloud infrastructure. In the ETL, the cost of a data warehouse is very high, but in ELT, because we use the data lake, the cost of the storage system are affordable. Is not very high, and nowadays in a new data pipeline, we use ELT. Okay, in ELT, you should use the cloud because you need separation of storage and compute, and in the cloud infrastructure, you have it. You can use the data lake in the cloud and then using some services in the cloud to transform this data, and you can run this service directly on your data you store it in the cloud. You need elasticity and on-demand processing of the cloud. When you design your data pipeline, some process can be run in parallel, and you can handle it by using the pipeline automation inside the cloud infrastructure. And also you can access to the managed analytics service in the cloud. When the data is ready, you can run this analytics service on your data. Okay, data transformation in ELT is bigger than we talked about in the previous slide. Just in the previous slide, we talked about data cleaning and data integration. But as Bill Hillman said, Bill Hillman is the father of data warehouse. He said the net result of transforming data is the ability to unify and integrate data. And once the data is transformed, you can view this data as a single entity. Okay, we integrate all different type of data into the integrate and single entity. And in the transformation, in the ELT, we can do another process on data, such as data enrichment or data structuring. In data enrichment, you can add some another feature to your data. For example, you have birth date, and you can add age to your data. You have the revenue for each sale on data, and you want the monthly revenue, you want the weekly revenue. You can add another feature to this data. And in data structuring, you can change the structure of data in order it is be ready to run any analytical program on it, and you see the result of this analytical model on a dashboard, or make it ready in order to go to the machine learning model. We do it in the data structuring part. Okay, for transformation, we have two types: batch transformation and streaming transformation. And in one system, in one data pipeline, you can have two of them. One pipeline for batch transformation and one pipeline for streaming transformation. In the batch transformation, you process large volume of stored data. You run it at a scheduled interval, and it is suitable when you want to report or providing report on some data. The batch transformation is okay. But a streaming transformation processes data in real time. Okay, it operates on continuous data stream, enable low latency analytic, and support real-time monitoring and alert on your system. We have different tools for batch transformation and streaming transformation. The popular one for batch transformation, as you can see in this slide, is Hadoop MapReduce. This is the system. You can process your data in a distributed manner. You can use Apache Spark. And for a streaming transformation, we have another software such as Apache Flink, Spark Streaming, or Kafka Stream. Okay, we talk about data pipeline. The first one is data generation, and then we ingest this data, and then we transform and then we store this data, and then we transform the data. In these next three slides, I want to talk about the storage system in cloud. And when the data is ready, or when you ingest the data, you can use these three type of storage for storing your data. The first one is data warehouse. Data warehouse support structured data. Okay, you can imagine it as a reference library. When a librarian wants to insert a book into the library, she should index this book before inserting. In data warehouse, when we want to inject data into the data warehouse, we should change the structure of this data in order to match with the structure of a data warehouse. Data warehouse has a table format. It has rows and columns, and you can't enter any raw data inside it, any type of data inside it. Okay, data, it should be converted into the internal format of the database. What is the downside of data warehouse? The downside is the cost of using the data warehouse. And we have some software in real world for managing the data warehouse. For example, one of them is Snowflake, The other one is Google BigQuery. You can work with these two software with the data warehouse. But data warehouse is not suitable for loading the data after ingesting into your data pipeline. We need data lake. Imagine data lake as a storage shed. You can put anything inside the data lake. It accepts everything: structured data, semi-structured data, unstructured data. Okay, your file can be CSV file, JSON file, image, PDF, video, voice, anything. You can store on a data lake. The downside of using the data lake is if you don't have a strict labeling, you can lose the data. And we call it data swamp. And accessing to the data in the data lake is very slower than data warehouse. In data warehouse, accessing to each data is very, very quick. But in data lake, compared to data warehouse, it is slower. The real world software for this in different cloud systems, when you use Amazon Cloud, it is Amazon S3. When you use Azure on the Microsoft system, you can use Azure Data Lake Storage. And when you use Google Cloud Storage, when you use Google, you can use Google Cloud Storage or GCS. Okay, this is the next storage system. And the last one, and the newest one, is Data Lake House. Data Lake House is a data lake, okay? But we have a managing layer. We put the managing layer on this data in order to query this data very fast. As I explained, the drawback of data lake is the access time to it is very low. It is very slow. By using the Data Lake House, you can handle this problem of the data lake. The data is stored in data lake, but we have a layer on this data lake. We have in these files for the data lake house, we can use open format like Parquet. We can use Delta table, and the popular software for using the data lake house is Databricks, Apache Hudi, and Data Lake. Okay, we store the data, but and we talk about different processes in transforming the data, and we talk about we need the automatic pipeline. If you need the automatic pipeline, you need to orchestrate this pipeline. Orchestration of pipeline means that you ensure about the running of different processes inside your pipeline. As you can see in this figure, it is a very easy pipeline. But in this pipeline, you can see two tasks as one of tasks is a sorting task, task A. one of task is ending task, task D. We have some arrow in the task. It means that the dependency of these tasks to each other. For example, task C can't be a start before task A is finished, or task C and task B can be run in parallel after task A is finished. Task D has a two dependency, and it is run when task C and task B are finished together. After that, task D can be a start. This is the orchestration. And in a modern pipeline, we have some software for orchestrating a pipeline. The popular one is Apache Airflow. The another characteristics of orchestrating pipeline is that it must be acyclic. It means that a task can't point back to the previously completed task. For example, when we have in task D, we can't go back to the task C or task D. And in the modern pipeline, we need the orchestrating, some software for orchestrating the pipeline because we need to run this pipeline automatically. Okay, we design a data pipeline, but it can't be run if we don't have data governance and security in the big data pipeline. As you know, in the data governance, we check data ownership. Who is owner this data? Data stewardship. Access policy to the data. Who can access to this data? And what is the usage rule? For example, some people can access to this data just for reading. Some of them can access to this data for updating. We need the usage rules. We should run data quality standard. We should check the data pipeline for compliance with regulation. For example, GDPR in Europe, we should check this data pipeline for the GDPR. And in data security, we should have some methods for authentication, authorization. If your data is sensitive data, you should encrypt the data. When you store this data or when you want to transfer this data, you should have an encryption method. You should have a secure access control. You should check the system and monitor the system for the threats. And we have data governance and data security inside all the stage of your data pipeline. We have them across the ingestion, storage, transformation, and then running the analytic on this data. Okay, I can have one practical example for data governance. You think about you have university student data platform. Okay, when a student register in a university, it should be registered in different systems. If we don't have any governance, you have this student in your LMS system, you have this student in your registration system, you have it in the analytic database, but any of them can use different data model. okay? Because we don't have any integration between this system. We don't have any governance. We have different format for the same field of the student. And if you don't have any governance, sometimes you miss the ownership of the data, and you can't define the access rule to access this data. And you have a risk of a privacy violation. But when you have a governance solution, you can define the data ownership. For example, the registrar office is owner of all of the records of students. The IT department is platform administrator. What is the access control? Access control rule. To access this data, a student can just view this data. Admin staff can edit the permission of, for example, lecturer. And lecturer in site definite period of time can access to the system to enter the grade. But after that, they have just read-only access to the grade. And if they want to change the grade, they should ask the admin staff, I want to change one grade in the system. We can have data quality rules. For example, a student ID must be unique inside the table. If we have mandatory field, they can't be null. We can standardize all of the data format inside the system, and also we can check it for compliance and security. If we have a sensitive data, we have some data encryption. We can have ID flag enabled inside the system. And in this system, we have the governance. Okay, we talk about all part of data pipeline. We start from the data generation, and then after data is generated, we ingest this data into the system by batch ingestion or streaming ingestion, and then store this data on a data lake, then run data validation on the system, on the data for checking the quality of this data, and then cleansing, integrating, enrichment, and restructuring of data. In this part, okay, this data is ready for analytic and for knowledge extraction. In the another session of this course, my colleague talk about how we can analyze this data and how we can run machine learning model on this ready data. And as you can see, along all of these stages, we have pipeline orchestration, okay? And we have governance and security. And this data pipeline is running continuously when you work with the streaming system. Okay, we want go to the real case study. All of us work with Netflix and see the TV series or film on Netflix, and sometimes we wonder when you click something on our platform, the recommendation of the Netflix system is changed accordingly. Why? Why is changed accordingly very soon? Because Netflix uses a continuous ingestion and continuous transformation inside the data pipeline. Netflix, what is the data sources for the Netflix? We have different data sources for Netflix. The first one is user click and watch history. Every click you do it, such as play, pause, search, okay? And every film or TV series you show, it is the first first data Netflix ingests by the continuous ingestion. The another data is device performance log. You can see a JSON file of device performance log of the one of the user of Netflix. This JSON file is created by your device, and you send it to the Netflix, and it contains your ID, your device type, your OS version, the ID of video you see, the speed you have this streaming, and your network time, your timestamp, you see this film or TV series. This is the device performance log, and it is created by you when you use, for example, browser version of the Netflix. It's created by your browser and sent for Netflix. The third one is content metadata. Metadata for the film or TV series, director. What is the name of director? What is the actor or actress? What is the production year of this film, and so on. This is the content metadata. And we have global streaming event. Global streaming event means the event that we gather it for a group of users. You can see it in this part. This is a device performance log, and you can see we collect this data for example, for Europe. We want to know this film in Europe has a viewer. What is the statistic of the viewer of this film inside the Europe? Okay, this is the data sources, and after that you should have a continuous ingestion to get this data. Netflix use Apache Kafka for getting any user click into the system. After that, it load this data into the Amazon S3. This is the raw data lake. And also, after you transform the data, you can, the Netflix, store some of data in the Amazon Redshift. This is the analytic warehouse system. In Netflix, we have two type of transformation. Batch transformation, it uses Apache Spark, and a string transformation, it uses Apache Flink. And after transformation, this data is ready and sent to the analytic software, and you can see personalized recommendation for you. Netflix can have some software for churn prediction model. it can use this data for improving the streaming quality, and also it uses this data to increase the revenue of this company. And we have the governance and business impact inside all of the stages of this data pipeline. Okay, we reached to the end of this session. We talk about big data pipeline as an end-to-end system with different stages, and as you know, each stage affects the downstream quality and outcome of another stage, and you learn about if you want to have a big data pipeline, we need cloud infrastructure as an operational backbone because it enables scalability, elasticity, it enables ELT architecture, and so on. We need data quality and governance during each data pipeline, and also all of the modern pipelines are automated and iterative, and we need the orchestration for this workflow automation. Okay, thank you very much for listening me, for your attention in this session, and I'm so happy to respond your question.
Thank you very much, Toktam. I would like to thank you for this interesting presentation. I'm sorry I was not able to welcome you at the beginning of the session, but I had some slight problems with the microphone, which I finally handled. I would like to introduce you and all of the participants for our trainings. This week we will have the training on big data for staff, for academic and non-academic staff of our project, the project Research University within Erasmus Plus Capacity Building in Higher Education program. The program aims to enlarge the knowledge of staff and students within our session, within our consortium. So the leader is Fırat University from Elazığ from Turkey, and the Western Balkans universities, which are University College for Business Studies, University of Bielina, Barleti University, Albanian University Center, Adriatic University Bar, University of Donja Gorica, and University of Mitrovica, in Kosovska Mitrovica. So thank you for a very interesting presentation.
Thank you.
For tomorrow's session, we also meet at 4 p.m. Polish time. We will have the meetings up to until Friday at 4 p.m. And on Friday, I will send to all of the participants a survey, which will be the satisfactory survey and self-evaluation center survey to evaluate our knowledge on big data and how the training is going on. So thank you for your presentation, for your time. We will see together in March for the presentation for students, for our students, and tomorrow we will meet with another presenter.
Thank you very much, Ivona.
If there are any questions, because maybe I interrupted, if there are any questions, of course, you can ask questions. But I guess there are no questions.
Yes, I can't see any question.
Okay, so in this case, thank you very much, and have a nice evening. Goodbye.
Thank you. Goodbye.